Hi, my name is Natalia Levitan, and my project for the CS29 class is Taming Text in the Wild, which is large image dataset processing for text recognition using Luigi. So I was faced a very interesting problem. A friend of mine who's a professor at another university gave me a large amount of images that he wanted to see that would be able using machine learning to recognize text within the images. And but the challenge is this images contain all kinds of forms of text. Sometimes they're street signs, sometimes they're things that are written on the trucks, sometimes they're things that are written on the shops. So how do you make such a large corpus of image data? Because what needs to happen, it needs to be processed in such a way that you can improve the contrast and make the sizes different. So to improve the ability to see and recognize text in such a variety of wild places. To solve this problem, I've set up a pipeline using Luigi. I am downloading images, a subset of images from AWS with S3. They undergo three types of processing in local directory. I am using Dask array, Dask image for storage because there's quite a few of them, and I output them for storage into H5PY file. Um, um, I have used the cookie cutter to create a template. I used AWS 3 bucket. I used Luigi to set up a pipeline. I used OpenCV to process the images and Dask images to create an array and use the HP5 storage format. So let me show you. So this is the three different kinds of image processing that I've done this part. Um, um, the images are resized using process images. Heights and width is determined here, set here. Um, the images are processed using adaptive threshold processing, which basically improves the contrast of them that makes uh, the uh, letters and numbers stand out. And I used Dask arrays for loading the images. This is actually the the process of what happens with the Dask image array. Dask image array is very useful because it implements certain filters that are very common to use for processing. It has functions for working with ND label images, and it has a very good morphological operators. And mostly it sets up tasks that are done in parallel, and it does things uh, because it's based on Dask array with different chunk sizes, which is quite advantageous when you work with a large amount of images and a large corpus of data, similar to what I have now. Lastly, I use H5PY, which is uh, have this function called output storage. And what it does is it allows you to use a large amount of numerical process data, like we have in images. And that the advantage of it is that you can slice it into very large data sets that can be stored in a disk and NumPy arrays. So the large amount of images can be stored in a single file and they can be categorized and tagged. So let me show you what it looks like. So this is my final project. I have, this is the structure. I have test files. I have the main file, which calls three functions: process images, output storage, and by segment. So in the Luigi function, I take a content image and I use Boto3 client to download the images from my S3 bucket called museum data, and this is the output into a path. I use this is stylized, and I use three functions. The process images the it takes the task from the download images. It requires the input of the download images. So I set up a DAG. What it does is it takes the images and it, based on the ratio, it resizes them and it outputs them into the out file in another directory. And lastly, uh, what needs to be done for better text recognition is done by segment, which uses adaptive threshold and uses open CV Python that processes images through adaptive threshold. I use, similar to one of our PSETs, I use uh, atomic suffix preserving local target, and I use requires and requirements. I've added here sorted output just to have it ability to, if you're dealing, for example, with medical images, you can use this pipeline and you can change the by segment to add any kind of different function to process the images for your machine learning pipeline. And that way, if you're dealing with patients and you want to preserve your patient data, you can use sorted output um, to um, to to create more privacy for the patients. So this is how you run it. Pipn run Python. Here also I have my environmental variables that I've set up in the Travis. So if I were to run it, it checks the files for the AWS bucket. It's downloading the images, the subset of images, and it does processing. And if you look at it, it creates several different folders. I did this in such a way that if you need the intermediate images, you can use them. So this are the original images of this data set. This is the output given this is the result of by process where it puts this through different through the OpenCV, and you can see that this image sets the text a little bit better apart than usual. This is small is the images that are resized for your other processing image needs, because often in machine learning pipelines you need to have images that are resized to a certain specific size. So if the image is not a constant ratio, it makes sure that the images are square. And lastly, it outputs the stored HDF5 file, which let's see um, how how large it is, and it is 2 megabytes. So the number of images that we had here, um, the number of images that we had here are like, I think 12 or 13 or something like this, and 2 megabytes output of the array is very small. So this is the pipeline. I think this process, this pipeline that is useful to set up, that you can use it in a scalable way to process different kinds of images for machine learning. And in this stack, we have used Luigi. We have used Dask image. We used Dask arrays. We had cookie cutter. We did unit tests, and everything is documented and pushed to GitHub and pushed to the Travis. Here are some references for Dask image. There's a Dask cheat sheet, and this is you can read more about H5PY file, which is really useful for everything. And thank you very much.